Okay, so we all know AI is reshaping pretty much everything, right? But what if its next great leap isn't just writing code, but actually mapping the very course of our health? Today, we're going to dive into a groundbreaking new model that uses the same tech behind ChatGPT to predict the future of disease. So, how exactly can an AI learn to read our health like a story? Let's find out.
I want you to imagine something. Your entire health journey, every single diagnosis, your lifestyle choices, all those key metrics, laid out just like a story in a book. Now, this isn't just a record of what happened in the past. It's a text, and it has its own grammar, its own logic. And if an AI can learn to read that story, well, it might just be able to tell us what happens in the next chapter. That is the incredible promise we're exploring today. So let's meet the star of the show, Delphi 2M. It's an AI model built on something called a generative transformer, which probably sounds familiar. It's the same kind of engine powering the most advanced chatbots we use every day. But here's the twist. Instead of learning from the entire internet, Delphi 2M learned from something way more personal, millions of human health records. And the scale here is just mind-blowing. Researchers trained this model on data from the UK Biobank, and then they validated its predictions against the health records of nearly 2 million people in Denmark. And the goal? To teach an AI to forecast the beginning of over 1,000 different diseases, all based on an individual's unique health story. So you're probably wondering, how on earth does it actually work? Well, the core idea is to treat the way diseases progress like it's a language. You know how words follow each other in a sentence based on rules of grammar? Well, health events can follow each other in predictable patterns over a person's life. Delphi 2M is designed to learn that very grammar. To do this, a person's health history gets broken down into a sequence of events, or what the researchers call tokens. Think of each diagnosis, like asthma or diabetes, as a unique word. Other things, like your age or whether you smoke or your BMI, are also turned into tokens. This whole process transforms a really complex medical history into a simple, ordered sequence that the AI can actually read and process. The whole process is actually pretty simple and elegant. First, the model takes in a person's sequence of health tokens up to right now. Second, using everything it learned from millions of other life stories, it recognizes the patterns, that grammar of how these health events are all connected. And finally, it does what sounds like magic. It predicts the next word in your health story. And not just the likely diagnosis, but, and this is absolutely crucial, when it's most likely to happen. Of course, a prediction is only useful if it's accurate, right? So the researchers put Delphi 2M through some serious testing to see how well its forecasts actually held up against reality and against the medical tools we already use. And let me tell you, the results are pretty remarkable. To give you a sense of its power, let's look at one of the most difficult predictions of all, mortality. The model achieved what's called an AUC score of 0.97. Now, what does that mean? In machine learning, a perfect prediction is a 1.0. A total guess, like a coin flip, is 0.5. So a score of 0.97 is exceptionally high. It shows the model has learned some really powerful, nuanced patterns about life expectancy. And this chart really shows you how it stacks up against the competition. For predicting mortality, Delphi 2M clearly outperformed the established clinical risk models, things like the Charlson and Elixhauser scores. I mean, these are tools used in hospitals today to figure out patient risk. The fact that this new AI model can do a better job and do it across a whole range of conditions is a really significant leap forward. And get this predictive power isn't just for the short term. Incredibly, the model can look a full decade into the future. And even when looking that far ahead, its accuracy only dropped a tiny bit. This really shows its ability to understand not just the immediate risks, but the long unfolding story of a person's health. But prediction is only half the story. The generative part of Delphi 2M's name, well, that's where things get truly futuristic. It can not only predict the next event, but it can also generate entire hypothetical health futures. Just like the researchers say, this is one of its most exciting features. The model can take a person's health record up to, say, age 60, and then simulate a totally plausible sequence of health events for the next 20 years. It can generate thousands of these possible futures, giving us a kind of probabilistic map of what could lie ahead. Now, this is a total game changer for a couple of reasons. First, it helps health systems plan for what's coming. But second, and this is the really revolutionary part, it lets us create completely synthetic, anonymous health data that acts just like real data. To prove this, the researchers did something incredible. They trained a brand new version of the model using only the AI-generated synthetic data. It never saw a single real patient record. And the result? This synthetically trained model was almost as accurate as the original. This is a massive breakthrough for privacy-preserving AI in medicine. So, a scientific breakthrough is one thing, but what does this actually mean for the future of medicine? This technology isn't just a research paper, it's a whole new blueprint for the entire life sciences industry. The implications are huge, and they spread across the entire healthcare system. For R&D, we're talking about smarter clinical trials and finding new ways to discover drugs by spotting disease connections a human might miss. For doctors and patients, it's the beginning of truly personalized medicine, where we can tailor screenings to your unique future. And for governments, it's a tool to plan for the healthcare needs of whole populations, decades in advance, all while pioneering new, privacy-safe ways to do AI research. This slide really puts it all into perspective. We're talking about a fundamental shift from a reactive model of healthcare to a proactive, predictive one. Instead of just treating diseases after they show up, we can step in based on personalized risk. It's a move from the medicine of averages to the medicine of you. Now, before we get too carried away, it's really important to remember that this technology is not a flawless crystal ball. To use it responsibly, we have to understand where its knowledge comes from and the limitations that come with it. Like any AI, Delphi 2M is a product of its training data. So if that data has quirks or biases, the model will learn them as if they're facts. For instance, the system learned to associate certain diseases with being recorded in a hospital versus a primary care clinic. Now, that has less to do with biology and more to do with the logistics of how data is collected. It's an artifact that the AI just mirrored. And here's a really concrete example of what that means. The UK Biobank data comes from volunteers, and volunteers tend to be healthier than the general population. So the model learned this healthy volunteer bias, which means its predictions might be a bit too optimistic when you apply them to everybody else. It's a crucial reminder that the quality and the context of the data is everything. We are standing at the edge of a new era in predictive health. A tool like Delphi 2M offers this amazing glimpse into a future where we can anticipate disease and act before it happens. The potential to save lives and totally transform healthcare is immense. But as we move forward, the most important question isn't just what this technology can do, but how we choose to wield it.